Hello everyone, hope you're having a wonderful day. Today I want to show you a little program that I made that checks for prime numbers. Right, so you input a number and it checks whether that number is prime or not. Let's run this program to show you it works. Okay, 7 is a prime number. Okay, 7 is a prime number, and let me show you how this program works. So you have a function bool is prime and it takes int num as an input. And in the main function, we define a number, print, enter a number. We scan for that number, so it takes as an input. And we go back to our main function. And the first condition we have is if number is less than or equal to 1, return false. It's not a prime number because 0 and 1 are not prime numbers and we don't check for negatives. And later, we have a for loop that checks from I equals 2 to less than the number itself for any divisor. So if num is divisible by I, that means it doesn't leave any remainder. So if after dividing I, it leaves a remainder of 0, return false. If divisible, it's not prime. And after all that checking is done, we return true if it did not return false. So it's quite simple. And let me show you, let me use a printf statement to understand the flow of this algorithm a bit better. So I'm going to clear this, run. I'm going to put another prime number, let's say 811. So, let's go. Okay, whoa. We have a lot of numbers here. So it checks from 2. Does 2 divide 811? No. Does 3, 4, 5, 6? So it checks whether these numbers divide this number or not. So they don't. And we keep printing, keep printing, keep printing. And we go from 2 to 810. So we check like 809 different numbers for us to be sure that 811 is a prime number. But if you notice something, if you think logically, we don't need to check, we don't need to divide 811 by 810 for us to know it's a prime number, right? Because we're just checking a lot of numbers. We don't need to check that many numbers. So I'm going to do something that might seem a bit weird to you at first. So we're going to check from I equals 2 to the square root sqrt of the number 811 in this case. And let's see what our program spits out. Okay, so we enter a number, we enter 811 again. Okay, now it checks from 2 to 28. I guess that's the square root of 811 and some decimals after that. And after we check from 2 through 28, we can for sure say that 811 is a prime number. But how can we say that after checking so little numbers? And there's a trick, because let's head over to the calculator over here. So 28 times 28, it's almost 3. Okay, so let's go with 29 multiplied by 29. It's a bit more than 811, but I guess it works. So if let's assume for a second that the square root of 811 is 29. So if we multiply 29 with 29, we get 811. And if we assume that it has a factor larger than 29 and it is multiplied with 29, like for example 31, it's going to exceed 811 over here. So if 31 is indeed a factor, it is going to be paired up with something smaller than 29. But remember, we have already checked for all the numbers from 2 through 28. So we can say that it doesn't have any factors, over the square root of 811. So I hope this makes sense. And thankfully, I'm quite proud that I actually found this trick myself without knowing that it's a thing. Uh, so yeah, this makes our code a lot more efficient, and you can do a bunch of more things, like, for example, define the square root of our number somewhere else and put it inside the loop so that our program doesn't have to calculate square root of num every time, every iteration of the loop. And you can also gloss over the even numbers, because even numbers can be a prime factor. So you can go with it starts on 3 to I plus equals 2 from 3, right? So it checks, and you need a separate condition, right? So I'm going to copy and paste this. Copy and paste. So if num percent 2 equals 0, return false, because if it is divisible by 2, return false, and we only check for the odd terms. So let's go ahead again. Okay, put a number. Okay, so we check for even less factors. So it's as efficient as it can be, I guess, hopefully. So I hope this worked. Goodbye.